the contour survey. But even now in our thing, it is rarely available, I would say. Then next comes the geology of the site and preliminary geotechnical investigations, followed by a detailed investigations. But I'm not sure in the presence of Professor, I'm sure you will also accept that the status in our country is still in very preliminary stage only. Though I know many of them are trying to bring it up. Yes, it is improving. We should quickly reach the standards, international standards. What is international standard is nothing but we are also part of that. There is nothing like an international standard. And whatever the investigations, what we do in some of the case studies, I will tell you how the investigations were done and what all the disasters that would have happened had that been followed.
Presentation share me.
Then the main process is the identification of a problem in our country. I don't have to tell that reason. We know that the explicit reason is the L1 criteria, right? So whether they are technically qualified to do these investigations for such a project is that also needs to be given an due importance. Yeah. See, recently there has been a code that has been given by our Bureau of Indian Standards, where it clearly says you get only the factual report from the investigating agencies. The factual report means only the field investigations, whatever we do like boreholes and ECPTs or other in situ tests, whatever you do in the lab, in the field. And only the relevant field test, what needs to be done from based on the soil that has been collected, get it done in the lab and get only the factual report. The interpretation report should be done by a qualified geotechnical consultant. Actually, a code has come recently in 2025, which clearly specifies the role of what is the role of the investigating agency, what is the role of the consultant. Yeah. Next is the evaluation of the performance of the structures, what that has been built based on the available soil investigation data. Whoever has given the design is either to have some settlement observations, which slowly it is picking up in India, but I would say it is like 1/10 or 1/15 of the total structures alone. The performance has been monitored. It helps in both ways. One is further optimization, whether the correlations that has been used are valid or how to further optimize it can be done only based on that. So this slide gives a summary of whatever I told you in the earlier few slides, the quality of the equipment that has been used and how to obtain samples at the site and the type of SPT, standard penetration test. All of us know how important is that N value for doing the correlations. Whatever correlations in respect of soil modulus or cohesion or angle of internal friction, whatever we get is all that is from the SPTN value. But how accurate are we getting that? Now, code is also mandating that you should use auto trip hammers, which lifts that to the standard height, whatever is required, and ensures the free fall also. Slowly, companies are getting used to it, and then many of them are doing proper SPT tests. One more is which is gaining popularity is the electric cone penetration test, which is no manual interference will be there. It is all automated. Just a cone would be pushed through the ground, and it gives you the friction ratio, which can be converted into SPTN. It also measures the water table. So this is how a standard soil investigation rig should look like. So earlier I had put a picture of what is being currently used here, but then process said, no, you don't put it, you just show how it looks. So then this is for boreholes, and this is with auto trip hammer, where you get the SPTN values. Then this is a typical electric cone penetration test. Yeah. I will quickly show one example of how this is what we have done very recently for one of our big project in National Capital Region. That soil investigation report came to our review. See, everybody knows how an SPT is being done, how electric cone penetration test is being done, how wind shear test is done, what are the tests you do, what is the procedure to do that. But half of the report was giving only what is there in the standard textbooks or in IS codes, the procedure, what is being adopted. Then the general geology of the site. Whatever the report we see, it is a standard thing. If it is in Gangetic plain or if it is in Yamuna belt, they give the standard cut and paste, everything which has really no essence of what is needed for this particular site. Then they give borehole diameter 100/150 mm. Then we asked what did he use, whether he used 100 mm or 150 mm. They said for the top 3 meters we used 150, thereafter we reduced to 100 mm. Similarly, they write as use of both calyx / hydraulic thing. Then we asked which one he used. One borehole we did using hydraulic rig, balance was used using calyx rig. So whatever is written in the report does not reflect what is being done at the site actually. So everything, whatever the standard size of equipments that needs to be used are not being used. If that goes that way, then the output also is expected to be in the same way. Yeah. See, this picture was taken recently in one of the sites where I visited. You can see that bent SPT sampler. You know the reason what they said when I asked, it was by mistake. Then I asked, where is the new one? He said, new one is on the way. But already they have finished some 7 or 8 SPTs using this. I don't know what he means by on the way. So we will start with one of the case studies where Professor about him when it was explained, it was told. This is for the foundations for the Sri Ram Mandir. So this is the typical section where there was a fill up. I think most of you must have read it in so many journals and other things. There was a fill up about 12 to 15 meters below the Mandir. Then we had the natural ground. The fill may be over a period of years. A small temples would have been constructed, which would have lasted after 50 years or something would have fallen, and then they would have just made it level ground and built. So like that over the period of so many thousands of years, finally this 12 to 14 meters of fill has come. Then the soil investigation report mentioned it as only fill because there are so many reasons for saying it also. They did not want to mention what the fill is, what it had contained. Then the target life for the temple was about 1,000 years. To avoid corrosion and other aspects, a decision was taken that no reinforcement or any metal will be used. Then a committee along with 7 members in which Professor was the chairman, Professor S.R. Gandhi and Professor T.G. Sitaram. They were also part of this committee, and then 2 options were discussed. One is to completely remove that open excavation and then go for that roller compacted concrete foundations for that. Other option is improve that ground using vibrostone columns, because vibrostone columns only will work there. But finally, they adopted for going with this open excavation, which was finally done and replaced with roller compacted concrete. The permissible settlement also, it was very stringent. They had only 12 mm, but finally settlements were measured using liquid level sensors, and it was observed to be only 5 mm. So that means it is a confirmation on, as I was saying, no settlement observations were done, and it confirms the decarbonizations or what estimations that have been done is validated. Second example I would like to give you is for this Delhi International Airport T3. Initially, it was given to L&T on a contract for using boat cast in situ piles because T2 was on piles. But the strata here is all excellent silty sand and sandy silt only. So when it came to our review, we said no piles are required. open foundation and isolated in the form of isolated footings is adequate. They executed it. The main advantage in that also is everybody knows that what are the disadvantages in, I won't say it as disadvantages, the difficulties in executing the board cast in situ piles in terms of proper cleaning of the bottom of the borehole, ensuring the mobilization of end bearing and all those associated things. Finally, they adopted open foundations here and they saved 6 months of construction time. So on a 12,000 crore project, construction time 6 months, saving itself, the interest component itself will be very high. And the next good thing is the airport is available for use 6 months. So GMR can start making it operational. Here also we insisted that the settlements be monitored. The actual predicted settlements theoretically was 40 mm, but they measured it very less. They said it's around 8 mm, or in some cases it was even 5 mm. Another example I'll quickly give is this is for an elevated expressway in Bangalore. This runs from Electronic Junction to it's called Silk City or something there. So there initially the piles were 1200 mm diameter. The target capacity, design capacity was only 670 tons. So they wanted to, as per tender, they have to go at least 1.5, one time the diameter into the granite. The rock was granite there. Then two things we did. One is we reviewed the initial load test. They did 1 or 2 tests, and then we said you can reduce the diameter to 1.2. Straight away, 1.5 is not needed. Then the socketing lengths also were reduced from 1.5 meters to 0.5 meters. This was given initially as per tender. That 1D penetration into the hard rock, and they did not discuss anything about what should be either in moderately weathered rock or SDR, soft disintegrated rock. Then based on these criteria, the piles were adopted and load tested. As you can see here, for 670 ton requirement, safe capacity everywhere, we got around more than 1000 tons or 840 tons. Minimum is 760 tons. This is with reduced socket length. So the reduced socket length itself was adequate. Yeah, this is another interesting case study where we did for a 51-story building in Gurgaon. As everybody was speaking, nowadays going taller is becoming the norm due to non-availability of land or urbanization. So here first the recommendations was given by, because this was done some 10 years back, because that time they hired a Singapore consultant. He gave the concept of pile-listed raft with a raft of almost 3,700 meters square, and total number of piles were 345 numbers he gave. Then the owners of this came to us and then said, if you have to do that, my project will be delayed by almost 6 to 8 months. Then we reviewed it, but they had a very stringent requirement of the pile-listed raft to be restricted to 50 mm, even though that time tall structure code was not there, but even then 75 mm could have been allowed. Then after the review, we reduced the raft area by almost half. It's only 1700 meters square. See the number of piles, it was only 94 piles. So it was almost reduced by 70%. This also settlement has been monitored. The predicted settlement was around 48 mm or so theoretically, but measured was only about 25 to 28 mm maximum that has been observed. So even this is conservative. What we gave is also conservative. Imagine had they done with that double the area of the raft and 70% higher piles. And this was the first time pile-listed raft was adopted in India. One more quick case study, what we did in Bahadurgarh. See, the recommendations were obtained from Soil Investigation Agency, because all of us know that Delhi falls under Zone 4, high seismic, just lower by to Zone 5. Liquefaction was an issue because of high water table and loose sands at the top. But recommendations was given only for boat piles. Then we said, no, you have to do ground improvement. Then vibrostone columns were done to mitigate liquefaction. Then only raft on top of it was given. Even here settlements were observed. The predicted settlements are close to 70 mm. the measured were around close to 58 to 60 mm. That means here also we are able to validate the correlation what that has been used. Yeah. So I think this so far what I have given where it's all in the national capital region. So since most of you are practicing here, I thought we should give one or two examples what we did here in Hyderabad. So this is for a commercial building in Nanakaramguda. The proposed configuration was 4 basements. That means 20 meters is the founding level. Then 24 upper floors. Only 3 trial pits were done. I repeat it, only 3 trial pits were done. You know the limitation of having the trial pits. You can't do deeper trial pits. So it was done only up to 3.7 meters depth. But our founding level is at 20 meters. With this, the recommendation was given for 40 tons per meter square. When we visited the site first time, we could even see the rock outcrops. So then we said, based on this, they wanted to adopt a rock foundation. You know the constraint in Hyderabad, it is all jam-packed. One side there are villas, and one side there is a school, and one side there is a 100-feet road. So you can't blast. So what will we do? How long you will be doing controlled blasting, and then when will you finish the raft? It's a commercial building. Then we said, first thing what we said is you don't need a raft. You do some 3 boreholes up to a depth of 3 meters below your founding level. That means if it is 20 meters, just get done up to 3 meters. That too, we want to see the continuity of the rock below the founding level. Then doing the borehole itself was very difficult for them. They were not able to do because it's such a high quality rock. Then they did only percussion driving. We said don't do any SPT or anything, just do percussion driving. Then they did percussion boreholes up to 3 meters below that. They could extract good quality cores. You can see continuous cores. Then we said, this is the founding level. You can see the sides of the excavation. This is at the founding level. Finally, we recommended 300 tons per meter square. All were adopted as isolated footings only. No raft was used. But finally, even based on the structural loads, what was coming, structural consultant said, I don't need more than 250 tons per meter square. One more case study. This is also in Gachibowli, L&T, Serin County. This is a site with 30 acres. There are 10 towers. All are 11 floors. Only 10, I think it was 9 boreholes were done for the entire area. But later the location of the towers also were changed. I don't know, for some vastu reason or something, taller towers were changed to the rear and shorter towers were moved to the front. So when it came to us, only out of 9 boreholes, only 2 towers were in the location of the towers. Because by that time when this has been done, all the towers have been shifted for various reasons. We were not only the foundation consultants, we were also supposed to visit the site before the raft or the isolated footing that is being laid. So for one tower, which was dimension of about 75 meters by 30 meters, 1/3 was on very hard rock, where you can go as high as 400 tons per meter square. One had muram, where we can go up to 80 tons per meter square or something. But the most critical part is 1/3 of the tower was on a soft clay. Imagine you had put a 11-story building on that. Without this, what would have happened? As our MLC was saying, it would have been like a pack of cards, cascading effect, and then you see all slabs falling one over the other. So then we wanted to know what is the reason. Then when we visited the site, this tower is at a higher level, and then as we gradually come out of the site, there is almost some 2 to 3 meter level difference is there. So there was a man-made lake in the behind this tower. So when earlier, when our human interference was not there, the water would flow, take its own course through from this higher level to lower level, and then it has passed through this. Then we alerted them to overlap all the tower locations and ensure to find out this the path of this man-made lake which flowed from higher level to lower level, and some 2 or 3 buildings also had to be moved to avoid the such things. Here, what we finally did is we took the foundations 4 meters deep in that 1/3 length alone, and that was completed. Yeah. So one more quick example also, this is again I'm moving back to NCR because most of the tall structures that has come up now till now is in the National Capital Region. So same here, initially it is a 30-floor building. Both cast in situ piles were recommended, but then we said you don't need a pile foundation at all. Then they went for a raft. The actual settlements, what was measured is only 30 mm. What was predicted is only was about 40 mm. Yeah, this is a very recent project in for Isha Foundation in Coimbatore. So nowadays, you know, there are so many visitors to this Adi Yogi, and they wanted to provide some accommodation for the followers of the Guru there. Initially, when they came to us, they were having in mind to go only up to 4 floors. Not to hurt anybody because that recommendation came from a structural engineer. He said beyond 4 floors, you need to go for piles. The strata itself is very good strata. It's all muram, and after certain depth, rock is starting there. So doing piles is also not feasible if you want to increase the size. Then we said you don't have to go for anything. Raft foundation is adequate even up to 20 floors. Then finally they adopted 14 floors for that same building. Maybe these are some of the old projects. Yeah. This is quite interesting. This is for an because this is another sector. This is a oil jetty in Tuticorin port, where the strata itself is it's a weak calcareous deposit sandstone. So a berthing structure was built and it was supported on boat cast in situ piles. Original decision, no, it was about to take the pile embedment depth 2.5 meters into rock. That means the total length of the pile would be 22 meters. Then the chief engineer of Cochin, I'm sorry, the Tuticorin port wrote to us saying that the project cannot be completed if this stipulation is to be followed. Then they came to us. Obviously, the cost is also shooting up for them. Then when it came to our review, we said, if you take the piles only up to half a meter or 2 meters into the rock, and it was tested actually. The test also proved that for the design load, this much of the socketing length, what that was given is much more than adequate. To take so much long was not correct on part of that. Yeah, I think this is the last project which I wanted to explain you. This is also for one of the dry docks on the west coast of India, which was recently commissioned. This is a stunning example. There were international consultants also, they were involved in this design. So construction also was done by one of the top construction companies of our country. There were 4,200 piles. You know, it was 600 dia, 800 dia, 900 dia, 1,000 dia. 4 diameters they gave. Length alone can be varied. Target capacities also was given. You know, for 4,000 piles, how many initial load tests were done? It was only 3. One for 600, one for 800, and one for 1,000. They did not do for 900 dia. Out of which one failed. Initial pile load test itself was failed, but they didn't redo it. But it's a major dry dock on the west coast. As per IS, if you have to strictly follow initial load test itself, there are 2 criteria you have to take care of for the initial load test. One is the diameter, and if the load carrying capacity is changing, the numbers have to be increased. Just for the number, 4 different diameter itself, they should have done 10 tests. There were, yes, I do agree there are site constraints because the pile cutoff level was 12 meters, but the pile was done from elevation, original ground level. But one more major mistake, what they did is they didn't want to skin friction to be mobilized for the top 12 meters because you are going to cutoff level is actually deeper. So they put a casing pipe, double casing around the test pile, just so that the skin friction does not mobilize. But that means you are making it as a free cantilever for 14 meters. I think this free cantilever, higher the length, structural engineers know more than us how difficult it is to do that. Load of almost 1,000 tons or 1,100 tons, 2.5 times the test load has to be applied there, and then they have to do the test. That also was not the appropriate way. The correct way should have been do it as a regular pipe without any double casing and then detect the skin friction for the top 12 meters or 14 meters, which will not contribute actually to the piles later. Certain things also, the spacing of piles which was adopted was not correct. The length of pile, because they did only one instrumented pile based on which they arrived at the shear parameters required for the design. Unfortunately, that was not correct. So they had taken optimum pile lengths, which was proved wrong during the routine pile load test. You can see that they did 40 routine pile load tests, out of which 17 failed. So later, rehabilitation is always costlier, right? So, but we managed to do some, they did some rehabilitation, and finally, the project was delayed by 2 years on such a huge magnitude. We know what is the implications. Yeah, I think with this, I'll conclude my talk. Making him his representative itself is a huge honor and privilege for me. Thank you, everybody.